Okay, class, so today we're looking at linear relations and we're going to do some notes of review of grade 9 and then moving forward. So linear relations are basically relationships that form straight lines. So we're going to focus on straight lines, what they are, how to draw them, and rearrange your equations in different forms and problem solve. So just review the basics of graphing here. Labeling the axis. So we have our x-axis and it's going in this direction with 0 in the middle. And so there's our x-axis. Our y-axis is going up and down. And we have 0 in the middle. And where they cross at 0, 0, we have a special name for that. Right here where they cross, that is 0, 0. And so that is the x-axis is first. The y-axis value is second, and we have a special name called the origin. Okay, so label the quadrants. We have quadrant 1. We hit going in anti-clockwise direction. Quadrant 2, quadrant 3, and down here we have Roman numeral 4 for quadrant 4. Ordered pairs again, we always have our x value first, telling you to go left or right, and then we have our y value telling you to go up or down, and they must be in brackets. So ordered pairs must be in brackets. So in each quadrant, we have in quadrant 1, all our x values are positive and all our y values are positive. Quadrant 2, our x values now become negative, but our y values remain positive. Down below, it's a very negative quadrant. X values are negative, and so are y values. Quadrant 4, now our x values are positive, but our y values are still below 0, so they are still negative. So each kind of coordinate, each corner of the grid has special x and y values to help you plot your points. Okay. Plotting points. So you always start with your pencil in the origin. Start at the origin. So I'm going to put my pencil there and I'm going to count right 3 and up 2. And the reason why, because those numbers are positive and that's direction of a positive coordinate for the x, 3. So I go 1, 2, 3 and up 2, 1, 2. Let me just move this 0, 0 down below. There we go. So 3 to the right. And then up to 1, 2. Then I can put a point, and that point we will label A. Good. And then we have negative 3.5. So as a decimal, that's negative 1.5. So I go this time to my left, 1.5. And so I'm not on a line. I'm going to be somewhere in the middle. Okay. And then I go up 4. 1, 2, 3, 4, right there, smack dab in the middle, that's point B. So I can label it with a B and put a point there. Negative 7, negative 8, so then I'm going to be going left 7, 1, 2, 3, 4, 5, 6, 7, and then down 8. 1, 2, 3, 4, 5, 6, 7, 8. And right there, I'm going to put the point C. Okay. Next one is root 7. So to check that out, I'll probably go to my decimal just to make sure that I plot it correctly. 2.6. So it's a little bit more than 2.6. So it's not in the middle. So now I'm going to go to the right 2.6. 1, 2, and 0.6 is right here in between 2 and 3, a little bit more than 2.5. Down 6. 1, 2, 3, 4, 5, 6. So right out there, a little bit more than halfway, and that is point D. So turning things into decimals can help you plot your points. Intercepts. Your x-intercept, okay, your x-intercept, that is where you cross the x-axis. So just remember that if you have a single one, it is axis, and then plural, you'll hear me say it as well, plural will be axes with an ES. Okay, so that's with Latin, how you go from singular to plural. For your x-axis, what that means is that since you're crossing the x-axis, your y value will equal 0. So you'll have some kind of number for x, but y will be 0. Okay, and so what we're doing is we are crossing this line there, which means we are not going up, we are not going down, because we're on that line. And so that's an important point. Okay, y equals 0 for your intercept on the x-intercept. You will need to know that lots. On your y-intercept, that is when you cross the y-axis. And so you're not going left or right, but you're just going up or down. So here we have our y-axis right here. So we don't go this way or this way, so that x value must equal 0 to stay on that line. And so that's a known value. I can tell you a value without telling you a value. X must equal 0. So you can make x 0 and find your y value to find your y-intercept. And we'll go over substituting equations and doing that later on. Filling out tables of values. Okay, so you always kind of need 3 points, 2 points for a line, and kind of a third point to check. Okay, so what you want to do is change equations into y equals. Then you can choose easy x values. If there is no fraction, the easiest x values ever are 0, 1, 2. You could go -1, 0, 1, okay, or something similar to that. But 0, 1, 2 gives you a really good idea. So what we do then is we substitute into our equation. So y equals 3x minus 3. X equals 0, so it becomes 3 times 0 because it's 3 times x. Equals 0 minus 3. Y equals -3. So when x is 0, y equals -3. Then you can do it for x equals 1. So y equals 3x minus 3 becomes y equals 3 times 1 minus 3. 3 minus 3, we're going to do a multiplication, and y value equals 0. So then you're going to do the exact same thing for the next one. I just need a bit more room here first. Slide this over. I'll do this one in red. So now y equals 3 times 3 minus 1, 3. Wow, that's a good one. And it's 2. Y equals 3 times 2 minus 3. Y equals 6 minus 3. Y equals -3. So now that I have 3 points, I can graph and make a line. So x is 0, y is -3, that's down below. X is 1, y is 0. X is 2, y is -3. I screwed something up, so I'm going to go back. This here value is wrong. That should be +3. And the reason why I knew it was wrong is because my third point would be down here. That is not a straight line. So I knew I screwed something up. I have 2 and 3. Good. So now I have 3 points. I'm going to make a straight line. I'm not going to do this. That is a line segment. Okay, you do not want to do a line segment. You want to make a line. So what do we know about lines? Lines go forever and ever 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 and ever. So how we show that a line is going forever and ever and ever is we do this. Whoa, that's huge. Let's go. Right there. Okay, let's try this again. There we go. So, arrowheads. Arrowheads tell us that it goes forever and ever and ever. Okay, so our lines must have arrowheads. I can't write today. arrow heads, or touch the edge of the grid. Okay, and which one would I do? I touch the edge of the grid. Okay, make long lines. So let's practice this one again. Here our equation is not until y equals, so we're going to rearrange it. We want to move this to the other side. So what's the opposite of plus 3? Minus 3. And so we then get y equals, making sure you line things up. Okay, line things up. The only thing that moves is that. And so we have negative 2x, which lines up and does not change. And then we have 6 minus 3, which is a result of plus 3. Now we have no fraction, so let's choose easy x value, 0, 1, 2. So let's substitute in x equals 0. So we get y equals negative 2 times 0 plus 3. Y equals 0 plus 3. Y equals 3. Let's do the next one. X equals 1. So y equals negative 2 times 1 plus 3. Y equals negative 2 plus 3. Y equals 1. And the last one, y equals negative 2 times positive 2 plus 3. Y equals negative 4 plus 3. Y equals negative 1. And so now we're going to plot the points and make a line. So we have 0, 3, which is up here. Then we have 1 and 1, which is here. 2 and negative 1, which is right here. And now we can make this nice, beautiful line. And so you can see I always use arrowheads, and I always make long lines. Okay, now I'm going to label it because I'm super smart. This here is line 1, and this here is line 2. You could also use the equation as well, and other teachers prefer different methods, but for me, this is fine, labeling it 1 or 2. Okay, moving on then. Graphing using intercepts. So remember with your intercepts, okay, well, there's two different kinds. We have our x-intercept, and our x-intercept is basically where you cross the x-axis. And where you cross the x-axis, what do we know about that spot? Y equals 0. Okay? And that's because we're not going up or down. And the other intercept is your y-intercept. What is your y-intercept? It is where you cross the x-axis. Okay? Sorry, y-intercept is where you cross the y-axis. My bad. And so in order to cross the y-axis, what do you know? You know that x equals 0. Okay, good. So let's go and then solve that. So we're going to put y equals 0 into our equation. Y equals 0. And so we had 4x minus 2 times 0 equals 8. 4x minus 0 equals 8. 4x equals 8. Divide by 4. So we're solving for x. Do the opposite of multiply. We divide. X equals 8 divided by 2. 8 divided by 4, which is 2. Okay? And so now we know a value to 0. Let's do another one. Now we're going to say x equals 0. So we had 4 times 0 minus 2y. Show your darn work here, otherwise you're going to not get marks. And so we get negative 2y. Okay, that's why you show your work. So then when the opposite of timesing by negative 2 is dividing by negative 2, and we get y equals negative 4. So that's the other intercept. X is 0, y is negative 4. So I can plot those two line points. 2, 0 is right here. 0, negative 4 is right here. and I'm going to make a line. So I want arrowheads, and I want it to be super duper long. Okay. Yeah, fix this one again. And that's good enough. And this is line what? Oh, it doesn't say, so I label it 4x minus 2y equals x. Equals 8 rather. Yeah. Okay, there we go. Next, I'm going to have some special lines to draw. Y equals -2. So what's that? That means that you're across at y equals -2. And so if you're crossing at y equals -2 right here, it doesn't make sense to draw a line here. What you want to do is cross to drawing your line here. So I will use my proper tool. It's called a ruler. And there we go up. Beautiful. Y equals 2. Okay. Whoops, -2. My bad. Down here, sorry. -2. Thanks for fixing that up. Here we go. Good. And then y equals -2. All right. And so what kind of line is that? That is what we call a horizontal line. Okay, like the horizon, it's straight across. And so x equals 5, that's where you cross the x-axis at x equals 5. So we'll find that here. 1, 2, 3, 4, 5, and we're crossing there. And the only way to cross is by going up or down. So special lines, you plot them slightly different because they only have one variable, so you know you're going to cross. It's just like an intercept, more or less. And I'll use the bottom over. And we get x equals +5. Okay, and that line we call vertical. So just reviewing last year's stuff. So let's just kind of review our solving skills. The key mantra you're going to hear me say is do the opposite. So you're going to do the opposite operation. And we've already seen that a little bit. So for example, if you have a square root, you would do a square, okay? And vice versa. If you have a multiply, then you would do a divide, and vice versa. And what's the opposite of adding? Well, it would be subtracting, and vice versa. So you're going to do the opposite, and my other mantra is keep it equal. So whatever you do to the left side, you got to do the right side. Okay, and so looking over here, we want to get x by itself. So we have x in an onion wrapped up in various things. We got to peel apart the layers, okay, in order to figure out what x equals. So everything must go on the left. And it's opposite bed mass, so we want to get rid of the adding by subtracting. And we get these cancel out. 3x equals 18. Always line up your equal sign. Now that's 3 times x, so the opposite of divide by 3, we keep it equal, x equals 6. Okay, then you multiply number 2. It's a little bit more complicated. We have to solve that by multiplying in. And so we're reviewing what we just did in grade 9 as well as this year. And we also add that together while we're at it. Okay, so we're going to do the opposite of minusing 12 on the left. We want to move this over to the other side. So the opposite of minus 12 is plus 12. And in order to keep it equal, we have to do it to the other side as well. And we're left with 6x equals 12 plus 12, 24. That's 6 times x. What's the opposite of times? Divide. And so we have x equals 24 divided by 6, which is 4. Okay, a couple other harder ones here. Let's add these together and multiply that out. So we get 6x equals 3x plus 21. So what we're doing is we're going to simplify the side before you move across the equal sign. Okay, so now my left side is simplified and my right side is simplified. So then I'll go and I'll remove the plus 21 by subtracting. Actually, you know what? Let's solve, let's do the opposite of 3x. So what is it? Well, this here is a plus sign in front. So the opposite then is minus 3x. Always look in front to decide what to do. So this would be 3x. These would cancel out, and you're left with 3x equals 21. Now that's 3 times x, so the opposite of times is divide. And so you're left with x equals 7. Now we want to do a check. So just reviewing our checks from last year, you always check with the original question. And you then have the Great Wall of Check fall down or develop, whatever you want to call it, and you don't cross the equal sign anymore because we're not solving, right? So a check means not solve. You got to do the check. And so x equals 7. So we get 4 times 7 plus 2 times 7 equals 3, 7 plus 7. So this would be 28 plus 14. This would be 3 times 14. 3 times 14 would be 42. And over here we would 30, 42 as well. And so the left side equals the right side, check. Okay, so doing checks, just a little simple way of correcting yourself and double checking. Next, so you got to simplify the left side, simplify the right side. So here we're going to multiply in. Here we're going to drop our brackets, but this is subtraction. So we will multiply in or add the opposite, whatever you want to do. Okay, so you got to watch out for subtraction. When you see subtraction, you have to change signs from the inside of the brackets. So multiply in, we get 4x minus 8 equals 14. And so now this comes from a plus x into a minus x, and this changes to a plus 3. So now that the brackets are dropped and your signs are corrected, now you're subtracting correctly. So let's simplify the left side. 4x minus 8 equals 17 minus x. Let's move this minus x. How would we move it? What's the opposite? Plus x, and keep it equal, plus x. And so we're left with 5x minus 8 equals 17. What's the opposite of minus 8? Plus 8. And so we're left with 5x equals 17 plus 8, which is 25. Divide by 5, so the opposite of timesing is dividing. Do that to both sides. X equals 5. There we go. So a couple things we're doing today. Number one is going to practice your graphing skills, or plotting points, drawing lines, substituting in and finding some quick little easy points to graph. Make sure that your line is long. It should have arrowheads or touch the edge of the grids, just like mine did. Okay, do not draw a short line segment, which is from those 3 points. This is a line segment, and we don't want the line segment. It is wrong. Okay, do not draw that. We want lines. Okay, so you can double check with me if you're not sure if you're drawing them properly. Then after that, we'll be looking at intercepts. Intercepts are extremely valuable for graphing. You need to really be able to find them easily because they hold valuable information for us. Okay, it tells us some important stuff in real life graphing situations. Special lines, which are vertical or horizontal. And then we have solving equations, and we also have rearranging equations, which we did up here with this question. So you always want y equals. Y equals is very important for us. Okay, there we go.